Welcome to DigitalOcean's webinar, using infrastructure as code to build reproducible systems with Terraform on DigitalOcean. Here we go. My name is Mason Egger. I am a developer advocate at DigitalOcean. You can follow me on Twitter at Mason Egger. If you end up having questions that you want to ask, it's very likely that we will try to get to some questions at the end, but there may be a lot, so you can always just reach out to me on Twitter, or you can always email me. mason@do.co is a good way to get a hold of me. Was my email and my website. This is my little artwork, my little awesome artwork by my graphic designer that I really like. As you can see, we all love Sammy here, our little shark buddy. So without any further ado, we're going to go ahead and get into it. So the goals of this webinar are going to be, we're going to learn about infrastructure as code. We're going to learn what it is, what the benefits are. We're also going to learn about one of the primary tools that is used to do infrastructure as code, which is Terraform. One second. There we go. Terraform has a lot of different offerings. We're going to talk about those. We're going to talk about how to install the Terraform CLI. We're going to talk about getting started with Terraform, learning about a lot of the Terraform primitives that are available. We're going to stand up different resources on DigitalOcean using Terraform. This is going to be a live coded demo. There are resources available that I will show in later slides where you will be able to follow along if you want. By the end, we're going to have a small load balance web infrastructure that we can stand up and destroy with a single Terraform command. So that's going to be pretty cool. If you'd like to follow along, you can go to, in your browser, go to do.co/IAC-webinar-code. This will take you to my public GitHub repository where all of the code is that we will be going over today. I will be live coding these examples during the demo and kind of, telling a story about it in the background while we go over it. So the code that is in the GitHub repo is the complete version of each of the 4 parts that we're going to cover. And I will be explaining in depth all the stuff that goes along with these parts. I also wrote some really good READMEs in there for you to reference later. And if you want to follow along, but you don't currently have a DigitalOcean account, you can also go to do.co/Mason and you'll get $100 credit for a month to play around with DigitalOcean. So if you do want to follow along and do these demos with us, feel free to go ahead and create an account and follow along. I think it's going to be a lot of fun. Okay, so let's go ahead and just get straight into it, talking about infrastructure as code. So what is infrastructure as code? Infrastructure as code is let me just read this real quick. The management of infrastructure using tools that take configuration files, these are usually declarative files, and accurately provision hardware to a known good state with every execution. So essentially that means is that it is a tool that takes in a configuration that allows us to accurately reproduce hardware configs. This is really valuable in cloud provider settings where you don't necessarily have access to your infrastructure, like the physical machine. So you need a way to be able to programmatically spin up and tear down your infrastructure to meet your needs. Idempotent is a big core principle of infrastructure as code. This means that execution of deployment always renders the same state. An example of this you can imagine are elevator buttons or crosswalk buttons. Whenever you push these buttons, it sets the state to, hey, I want to call the elevator, or hey, I want to, cross the crosswalk. Pushing that button will in no way speed up the execution. You can run it as many times as you like. Execute in the state that you want, and every other execution of it also leaves it in that same state. So that is the definition of idempotent. It took me a while to figure out exactly a good way of explaining that and how for myself to even understand it. So I really like that metaphor. What are some of the benefits of infrastructure as code? It allows us to create reproducible infrastructure. This is really valuable for us to be able to always know that whenever we stand up infrastructure, that we know it's going to come up in the same state that we had it before. If it doesn't, then we will get problems. It is easily redeployable. As you will see in the demos that we do, it is very, very simple to redeploy infrastructure with Terraform. Usually it's one command. So we can tear down, stand up, plan our infrastructure with minimal commands, and we just know that it's all going to come back up. It is a solution to infrastructure drift. This is a big one. Very often, whenever you're running large fleets of machines or even small fleets of machines, maybe the web server goes down or something, or maybe something happens where you have to SSH in or access your server to do a one-off fix. Maybe you have to tune some kernel parameters or something, or reset some firewall rules or something along those lines. And this leads to infrastructure drift, where parts of the infrastructure are not the same. It's not all the same across all of them. You may have 10 machines and you had to SSH into 3 of them to tune something, and now your infrastructure has drifted. And this becomes a problem, say, if you need to redeploy this infrastructure, if it wasn't properly documented what you did, or any of that, it's very likely that you will forget these configurations. And then when you redeploy the infrastructure, you can produce an outage because you forgot what you were doing, and it was, your infrastructure drifted and you didn't really know that it was going to drift that way. So infrastructure as code, I would say, to me, it is the fact that it's a solution to infrastructure drift. This is the biggest draw to me using this as a past SRE, because the drift is really bad, especially when you have fleets of thousands of machines and you can't possibly keep up with all of them. The configuration code that you create, the configuration files, can be stored in version control, which is really good because then you can see versions of your infrastructure. You can go back 3 years ago and see what type of servers were we deploying, what type of firewall rules did we have set up, all of that. So the fact that we will have history of our infrastructure is a very good thing for us, because will help us hopefully with planning, with infrastructure planning, and how many resources do I actually need? How much do we predict we're going to need during peak season, during this peak travel time? So it is a very useful thing to have it stored in version control. It's easily automatable, which is really good. Terraform is built to be extremely automatable, so you can have you say you make a change to your infrastructure and you push it to GitHub, CI/CD can pull it down and it can automate the entire process of updating infrastructure. So automation is good. And okay, but you might be saying, hey, wait, I use something like Chef or Puppet or Ansible or SaltStack or whatever flavor of tool that you can think of. And yes, are these infrastructure as code? Technically, these are not infrastructure as code tools. These are configuration management tools. Their jobs are to configure resources that are already provisioned. Provisioned, the way I like to think of it is provisioned is the hardware in OS level. So like I have a server and I have my hypervisor spun up on it and I have the operating system installed. Or if I'm using cloud compute resources, I have 4 DigitalOcean droplets ready to go. They have the basis of the things that they need installed, like the operating system. They maybe have some firewall rules. Maybe we have some load balancers, some DNS records, all of that stuff. That is the kind of the provisioning level. But I will say there is some weird overlap. Like what I just mentioned, DNS levels, that could also kind of go into the configuration area. It just depends on how you really want to do it and where you see the separation at. Configuration, on the other hand, is the software package level. So this is, I'm deploying a Python app and I need Python 3.8 installed and I need to, set up my virtual environments and, deploy it. Say if we're doing on bare metal, or, maybe installing Docker and getting it going from there. This is the configuration level, and these are the type of tasks that the configuration management tools such as Ansible and Salt typically have solved in the past. Infrastructure as code and configuration management tools are not replacements for each other. They work together. Like you will need tools for provisioning your hardware and you will need tools for configuring your hardware, but you really will need both. Now, I do know, and I do think that maybe some of the configuration management tools such as Ansible and Salt, I'm pretty sure Salt Cloud can do provisioning. It's been a long time since I've looked at it, so if I'm wrong on that, I'm sorry. But it could be, you can maybe use it for it, and that's up to you. It's all about finding the tools that work best for you. In the DevOps and the SRE realm, there are so many tools and there's so much to use that it's really about finding a tool that A, you like, I can't do a bulleted list in my head. A, that you like, B, that you trust, and C, that you think is easy enough for everybody to be able to pick up. If the tool doesn't work for you, don't use it. Okay, like the worst thing you want to do is being paged at 3 a.m. because your infrastructure is down and you can't remember how to write, proper Puppet spec code because it's, kind of Ruby-esque. An example of using infrastructure as code and configuration tools together is using Cloud Init. So at my previous job, we used Terraform to stand up all of our cloud provider resources, basically all of our compute resources that would stand up, the EC2s and the droplets and whatever GCP calls theirs. And we would stand all that up, and then we would use Cloud Init, which is a initialization package that's built into most of your modern, virtual private servers that are deployed on clouds that will allow you to write small snippets of provisioning code that will execute maybe some bash or really Cloud Init has like a YAML configuration that it can take. But we would do this to have the code automatically join our Puppet clusters. So this is an example of them working together where we bring in together, we use infrastructure as code and Terraform to stand up our resources, and then we would use Cloud Init to set the key and all of the appropriate things needed to join the Puppet cluster, and then the Puppet cluster would detect that, hey, there is a new server, now allow me to automatically provision that or configure that. So these do work in tandem very well together, but it does take a little bit of coding to get that to go. So next thing we're going to talk about is the infrastructure as a code tool that we're going to cover today, which is Terraform. Terraform is largely, for the most part, open source. There is a Terraform Enterprise, but in reality, I don't think that Terraform Enterprise has any features regarding the provisioning that is locked behind the enterprise wall. I think enterprise literally just has to deal with on-premise state management. So it's a tool that is made by HashiCorp. The very amazing company. A lot of the tools that they build are just absolutely top-notch. So they have this. It's a really cool infrastructure as a code tool. There are two-ish main offerings. There's the Terraform CLI. This is a Go binary that you download and run locally on your machine. And this is what we will be covering today. We're only going to be covering the CLI. We are not really going to go over much of the Terraform Cloud and the enterprise models. But just for a little bit of context, Terraform Cloud is essentially remote state management with very good version control and CI/CD integrations. So as you're going to see later when we're using Terraform, when we're executing it, Terraform Cloud just allows it to be executed and somewhere else, like in their cloud, and then the state is managed by them, which is actually a very valuable thing. Having state management is one of the, I'm not going to say trickier parts of Terraform, but it is definitely one of the things, it's a very important thing that you have to make sure that you're doing correctly. There are tiered levels of this cloud. So there is a free tier, I believe, but there's also like, I want this many users for my team and I want these integrations, and it tiers all the way up. Terraform Enterprise is essentially the same thing as Terraform Cloud, but with all the enterprisey bits essentially. So it's a self-hosted distribution of Terraform Cloud on in your data center. So if you're still running private data centers, you could potentially host this internally to yourself. Also, it has the enterprisey bits like single sign-on, SAML integrations, stuff like that. I don't know if Terraform Cloud has it, but I remember specifically seeing that on the enterprise page, so I know that they have that. There are hundreds of providers for provisioning many different types of resources, from DigitalOcean to AWS to Datadog to just all sorts of things. And then there is a registry that they recently launched of community-built modules for building different types of infrastructure. So say maybe you want to build the same stack, that we're building today, but you want to see how other people have done it. You can go and view other people's things in Terraform registry and just download them and use them yourself if you want. You don't have to reinvent the wheel to every time you want to write Terraform. You can easily, hopefully find somebody else's code that's already done it. And if you want to install Terraform today so you can play along, you can easily do this from the download Terraform page. So it's terraform.io /downloads.html. And essentially what you would do is you would come and find your operating system. So Mac OS, Windows, Linux, FreeBSD. Oh, I love that they have an OpenBSD installer. That's I'm an OpenBSD fan, so that's really cool. They have Solaris. That's also pretty cool. So you just easily come over here and you download it, and you basically unzip it, and it's a single binary. You can run it locally inside of your directory, or you can do what I did, which is I put it in my user local bin, so that way it's accessible in my path. Okay, so I've talked enough. We've done enough talking. Let's go ahead and build some infrastructure. Let's actually, get into the nitty gritty of Terraform, and let's actually build some stuff. So this presentation is divided up into 4 parts, each one building on top of the other. If you are looking at the code in GitHub, you'll see that a lot of the code is replicated throughout, because I did decide to kind of cover certain things in distinctive areas, and we're going to go over it there. So the first part is actually going to be, I'm going to call this like the hello world of Terraform. There's actually not going to be any resource provisioning. There's going to be mostly just talking about some stuff and doing a simple output with some hello world. So we're going to cover providers, variables, and data sources. Providers, these are essentially modules for different resources. So when someone says a Terraform provider, we're talking about the little pluginable part of the Terraform architecture that allows us to provision that resource. So there is a DigitalOcean provider that provides all of the Terraform resources that we need to be able to create DigitalOcean resources. Example, there's DigitalOcean, Kubernetes, Datadog, AWS, all sorts of different providers. There are, I think, if I remember correctly, over 100 providers for all of the different resources and stuff. So it's a really, really large and vast tool. The likelihood is it's very likely that you will be able to find the provider you need to provision the infrastructure that you need. And if you can't, you can easily write a provider because all of the providers are open source. Data sources, ways of getting data from your provider. So this is essentially, there's 2 different types of resources inside of a provider. There's a data source and then there's a resource. We're going to cover resources in part 2. But a data source is like, hey, I want to know what some of the limits are on my account, like how many droplets can I spin up, or I want to be able to get the ID of my SSH keys and stuff. These are providers that simply just go and read information from the resource or the like DigitalOcean and brings it back to us. We can get account information out, resource data, and all that. Variables, these are basically input for providers. Essentially, they're just like variables in a programming language. There's 2 different types of variables, however. There's input and output variables, and we are going to cover those in the code. So if I switch over to my VS Code and my terminal, I will be able to go ahead and get started. So actually, before we do that, let's cover one other thing. Whenever you're working in Terraform, your best friend is going to be the providers page. So you're always going to want to be able to see like the providers and be able to access what you want to be able to do. So like here, like these are just a list of all of them. There's a Grafana provider, there's a GCP provider, there's a GitLab provider, there's a Kubernetes provider, and all of that. So when we just look for the DigitalOcean provider, and now we are in the provider page. So basically, this is usually the main provider page tells you how you're going to access the resources within DigitalOcean. So we recommend using a variable for your token and then passing your token in to the provider. This token is essentially just an API key that you would get from DigitalOcean. And then, as you can see over here, there are data sources on the left-hand side in this little woohoo right there. And these are the data sources that you use to get information out. So like for the account, I will create a DigitalOcean account data source. We will give it a variable name that we want to call it. This one called it example. We will do ours. And I will be able to pull this data about my account out of it and view it. And then the other thing you have to note is that there are also resources, and these resources, so like say DigitalOcean Droplet, are the resources for actually provisioning. Now, one of the things that I will say that trips up people every time is the difference between the data source droplet and the, it's not very obvious which, if you're in a data source or if you're in a resource. And the amount of times that I've spent reading the data source thing and going, what do you mean? It's not taking these arguments. And then realizing I wasn't in the resource droplet, it's a non-trivial amount and it makes me sad. So one thing that I always do is up in the URL, you will see like docs providers, DO, and then this will be the provider name. There's going to be an R for resource and a D for data source. I always double check that just because I've made that mistake too many times. The resources and the data sources are typically named the exact same thing. And to me, it's not always overly clear which are which. So I'm going to be hopping back and forth to this page a lot because we're going to do a lot with the resources, and it's just a great way to be able to like know exactly what you need to do. So into the coding, we're going to go ahead and start off by defining a variable, just like the data source said, DO token. And if I could spell, we'd be good. And I am using VS Code with the Terraform plugin. We are also, I should have mentioned this earlier, we are using Terraform version 0.12. If you have been using Terraform before in the past, you'll know that from version 0.11 to 0.12, there were some major breaking changes in the way that the HCL is written, the HashiCorp configuration language, which is the configuration language of this file. The autocomplete and some of the fill-ins and stuff in my VS Code extension sometimes hate me and tell me that it's wrong when it's not. So if you see squiggly red lines, it can mean that I'm wrong, but at the same time, it may also just be the fact that the autocomplete hates me. That happens a lot. Okay, so the next thing we're going to do is we're going to create the provider, which is DigitalOcean, and we're just going to say var.do token, and we are not going to be showing that while I'm doing this. Oh, look, the autocomplete worked. So whenever you have a variable in Terraform, you can assign it to, you basically put it in for, hey, the token, we're going to use this variable, it's going to fill in. And basically var.do token, you access it with var and then the name. So the name that we gave it up here is how we access it down here. Then we are going to say data DigitalOcean account, and we're going to just call this account info. And we're going to just do the parentheses. Very often with the data sources, they don't typically have a whole lot of input variables, or at least this account info one doesn't. Yeah, see, like you see, it's squared right. It doesn't say this doesn't exist. Oh, I know why it doesn't exist. I haven't gotten to that part yet. So don't really worry about that too much. And then we're going to do an output droplet limit. You have to be able to spell it right. If you call it dorplet, it does not work. And we're going to say value equals data dot DigitalOcean underscore account dot account info dot droplet underscore limit. Okay, and I'm going to pull this. Oh, if I get rid of this, we'll be able to see it all. Okay, so I just did a lot really quickly, and I'm going to go over it real quick. So variable DO token is essentially just us creating a variable. We have a variable now that we can pass in either via the command line through a variable file or through environment variables. I'm going to go over that in a second. We have said, hey, the provider that we want to use inside of this file is DigitalOcean. So we want to use DigitalOcean to be able to access our stuff. We now have a data provider saying, hey, the DigitalOcean data account, which is the exact same one that we saw over here in our account, and we gave it a name of account info. This variable, usually this name is whatever you want to call it. The DigitalOcean account is very specific, and it has to be that, so it knows which data source to get, but then you give it a variable name in case you need to be able to, you want multiple data sources of the same thing. It doesn't make a lot of sense for account info, but we're going to see an example in part 2 where it does make sense. And then we're going to create what's called an output, or an output variable. So when Terraform is done running, it will output whatever is in this value. And then to access all of the data that we have inside of this account info, we say data like this, then DigitalOcean account. So we have to say this data source, the type of data source, it was a DigitalOcean account, the name of the data source, which was account info, and then the name of the attribute that we want to see, which was the droplet limit. So now that we have this all set up and saved, I'm going to make sure that it is actually in my code section, and it is. The first thing we have to do whenever you start writing Terraform, the first thing you always have to do is do a Terraform init. So what this does is this will look in the directory for a Terraform file. It will read the Terraform file and parse it and see, hey, which providers are you actually looking for? In this case, we only have one provider in here. We're looking for the DigitalOcean provider. So the Terraform code went and immediately downloaded the Terraform provider and put it basically in this directory. So Terraform works off of a hidden directory called .terraform, and basically it's directory based is the scope of your Terraform files. So if I were to go out of this folder and try to run Terraform, it would be like, hey, I don't know what's going on because it's not in the same directory. And then typically, once you do a Terraform init, let's see if I can, I think if I close my main.terraform and then I double reopen it, it gets rid of the little red squiggly. So now my thing doesn't hate me quite so much. So we've done a Terraform init and we're all good to go. Now, the next step that you typically run with Terraform is you run a Terraform plan. This will go ahead and run basically what it does, it creates a resource dependency graph or resource graph of all the things that it's going to either change, add, or delete, and then it will output them here. Since we are doing just a data source and we are doing output, it says there is no changes to be made. You have your infrastructure up to date because we're not changing any infrastructure. We're literally just reading it. So now that we have that, we can run a Terraform apply. And it outputs your droplet limit is equal to this. Now, because I work at DigitalOcean and because I do a lot of testing and stuff, I have a relatively high droplet limit of 1,000. Most people, I believe the default droplet limit is 25. Don't quote me on that. So now you can see like the output for this, and really and truly, that's the very beginning. This is what I call the hello world of Terraform. We got some data using our data source provider, and then we did an output for the droplet limit. And we should be good. Now we're going to go back over to our next part, and we're going to go ahead and move into part 2. And I need to pull up my code in this section because while I know exactly what I'm doing, I guarantee you I will make a typo and get it wrong. So part 2, we're actually going to start creating resources. So we're going to create a resource. So now that we have my data out, I want to create, a very simple resource, and, just maybe let's create a little simple web server and a droplet. So resources are objects that can be created from your provider, and the example for these are load balancers, DNS records inside of DigitalOcean, droplets, literally everything. I think we have a Terraform provider for everything. For every resource that we offer, we have a Terraform provider for it. So we're going to go back to our code. And we're going to make some quick adjustments. The first thing we're going to do is we're going to get rid of our output and our data because we're actually not going to need the account info for this data source. That was just an example to show for a hello world. What we are going to do, though, is we are going to do another data source, DigitalOcean SSH key. So, got to put the quotes. And we're going to call this home. So what we're going to do with this is this data source is going to allow us to look up SSH keys that are inside of our DigitalOcean account, so we have access to them later in the code. So my SSH key in DigitalOcean, I have one called Home Desktop, and then I also have one called Work Laptop. So we're just going to add those up real quick. And we have the 2 data sources. Now I will be able to access my SSH keys. And if I want to be able to view that from over here in the data source, as always, we go over here. And the only requirement for the data source is the name of the key. So we give it the name of the key as it would show up inside of DigitalOcean. And these are all the attributes that we can get back from it. We can get the ID of the SSH key. We can get the public key of it. So we can get which is actually just the key that's in there since we have our private key on our machine. And then we can also get the fingerprint of it if we want to be able to do some sort of fingerprint verification of our keys, which is really nice. So we're going to go back over here now. Actually, no, we're not. I lied. We are now going to create a resource, and we are going to go into resources and look for droplets because we are now going to create a quick, small little droplet in DigitalOcean. So example usage right here, resource, DigitalOcean droplet web. Image, it's using the Ubuntu 1804 image. Name, we just randomly called it Web1. This is set in the NYC2 region. This is the data center where our resources are put. And then we have the size, which is just our standard droplet, 1 virtual CPU, 1 gigabyte. So one thing you learn about being an SRE is never write any code that other people have written for you. So there's no reason for that. However, I don't like how that indentation works because I have a pretty indentation thing and the red was bugging me, so we are going to fix the indentation. And then the only other thing we need to add to this is we need to add SSH keys, and then we're going to access the SSH key IDs from the data sources that we used earlier. So we do a data.digital ocean underscore SSH underscore key dot home, which is the name of the variable that we used up here to identify it, dot ID. And then this is a list. So the SSH keys does take a list as its input. We are going to do, I don't want that many tabs. We're going to do the other one and make sure that we add my digital, I cannot spell today. Yes, we're going to add my work key as well, just to demonstrate how you can add multiple keys. Why do you hate me? What's it say? DigitalOcean, data.digitalocean.sskey.work. Oh, I double called it home up here. Whoops. Fun thing about copy pastas is that sometimes you make mistakes like that. And then the other thing we want to do now is we want to get outputs from our droplet. So what we're going to do is we're going to go back to our resource group and we're going to see, these are the arguments that the resource can take. So image, name, region, size, these are all the required arguments, but there are other arguments. Backups, monitoring, IPv6 if we want an IPv6 address, private networking. You don't even really have to send the SSH keys. If you don't, you will be emailed a one-time root password to your email account that is associated with your DigitalOcean account. I personally just prefer to put the SSH keys in. Resizing the disk, whenever you want to resize the droplet, you set it to true. Yeah, I read that wrong. But yeah, so basically how to resize the disk, tags, user data, which we will go over later. This is where the Cloud Init stuff comes in, and the volume IDs. Now, these are the arguments that you take in. The attribute reference are all of the values that you can get back from it once the resource has been created. And the one we're looking for right here is the IPv4 address. So if we go back to VS Code and we say the value that we want is equal to DigitalOcean droplet.web.ipv4 underscore address. Now, whenever we create our droplet, we will get the address back. The IPv4 address, kind of similarly to how we did droplet limit over here, we will get the IP address back. Do note that when you access a resource's attributes, it is only the name of the resource, the name of the variable that you gave the resource, and then the attribute. Unlike variables, which, var do token, or data sources, which use data, they chose not to do a resource.digitalocean.droplet.web.ipv4 underscore address. Personally, I kind of wish they did. Would have made the consistency around it a little bit easier, but hey, I'm not the one writing it. So now that we're over here, we have made sure that we save and we run a Terraform plan. We only ever have to run the init the first time. Now, if we were to delete our provider here, or we were to add a new provider, we would want to rerun the init. I don't think if you delete a provider that it will remove the provider from the Terraform directory, but if you add a new provider, it will. So as you can see, we only put in like 5 things, but we're getting all of this data back from our Terraform saying, hey, this is all the stuff that you have. These are all, if I remember correctly, these are all of the these are all of the attributes that you can see from Terraform. So even though we didn't actually use any of these, we can still access these attributes. Some of them might come back as null, or some of them we have no access over. Like we can't change how much the price hourly costs for this, but we can access that attribute once we create it. So now what we do is we can just simply run a Terraform apply. And what this is going to do is it runs something very similar to plan, and it will drop out very much of the same data. And according to the plan, we have 1 to add, 0 to change, and 0 to destroy. This 0 to destroy is something you always need to be checking, and it is something that we'll go over in the next part. But Terraform, the way that Terraform stands up and tears down infrastructure and changes things, sometimes can lead to stuff being destroyed and is redeploying. That can cause issues with, that can inadvertently cause unexpected outages if you're not paying attention. So it's going to ask us, hey, do you want to actually apply these things? So it always gives you the option. There is an auto apply flag that you can set to Terraform apply, which I may start using later. Not recommended for prod environments. Even when we ran all of our infrastructure at my last job, none of our Terraforms went out without a manual intervention. I know that may seem sort of counterintuitive, because, you know, it's like, well, if humans, and well, why are we using humans when robots can do it? I get it, but at the same time, it's always a good idea to like just double check that destroy, because there were a couple times when if I had hit yes on it, I would have tore down all of prod, and that would have been really bad. So we're going to hit yes, and it's going to start creating a DigitalOcean droplet. And now we just wait. Suspense is terrible. I hope it'll last. Plus 5 points to Gryffindor for anybody who knows what movie that reference came from. If you do know what reference that movie came from, tweet it at me, because I want to see how many people actually do know it. Okay, so now that we're done, we have a droplet, and the server IP was spit out to us. So if we go over to our project inside of DigitalOcean, we will see that, yes, we do indeed have a droplet inside of DigitalOcean spun up. So, and if I go to the IP address, I imagine nothing's going to happen because there's nothing configured there. So let's just do that real quick. Let's just SSHN root at 192.241.252.42. Yes, and got it. Cool. Apt upgrade. Is it upgrade or update? I think it's update. Ooh, we're going to figure out. I came from a Red Hat world. Don't blame me. An apt install -y. We'll just say HTTPD. Or is it Apache? You know what? Nginx. I don't remember what the package is called on Ubuntu. But it was update. That's good. I spent a long time working in Red Hat systems, so I'm really used to Yum and DNF, and now I just use Ubuntu for a lot of my demos, and I'm getting used to the apt stuff, but it still throws me for a loop every now and then. Okay, and systemctl. Hey, I'm looking at the chat. People got that movie right. Hooray! Systemctl start Nginx. Oh, yes. And the people that are talking about my SSH key password, yes, I am insanely paranoid about stuff that I have no reason to be paranoid for, because I have nothing of any value, but all of my passwords are at least 32 to 64 characters in length. And I don't use a password manager because to me, it seems like a single point of failure. We can discuss that on Twitter. So we have started that, and now I think we just go over here to the, yes, and now we have our Nginx page. Okay, so we have really quickly spun up a droplet in this section, and we're ready to go, and we're just going to get onto that. Now, let's say, hey, I don't need the server anymore. We're just going to go ahead and destroy it. So Terraform destroy will come up, and it will tell us all of the things that it's going to change, basically setting everything to null and then kicking the resource out. So if we hit yes, and then if we quickly go back over here, and maybe we pull it up over here. No, I want it right like this. Because if you watch it, you'll be able to see it drop off from, there it goes. So as you can see, the droplet was removed from demos, and then the Terraform will come back as the API is finishing up some of its cleanup. And the resource has been destroyed. So that is very simple resource management. Like that's a single resource that has no dependencies on anything else. You can kind of say that maybe it has the dependencies on the data sources, which is pretty, but you don't need it. We're going to cover more dependencies in a later one. Where am I going to now? We're going to click VS Code, and then we're going to go back to my slides. Where are they at? There they are. Okay, next section. And I'm doing okay on time. I'm actually really happy about that. Okay, our next section that we're going to cover is parameterizing our files and workspaces. We're going to use variables. Also, one day I'll learn what grammar is. We're going to use variables to make Terraform more reusable. We're going to use workspaces to create an isolated areas for our Terraform states. And we're going to allow for different states to be applied with the same file. We're going to, if you've worked in Python or any sort of interpreted language that has like something similar to virtual environments, think virtual environments. It's basically an isolation for Terraform states. Now, you may be asking, well, why do I need that? I'm actually not going to tell you right now. I'm going to show you basically what happens when you don't do this, and then I will introduce the solution, which are the Terraform workplaces. So Where is my part 3 code? Because if you think that I'm not reading this code off of my GitHub while I'm writing it, then you are silly, because I'm totally not taking the chances of messing that up. Okay, so we are going to add a couple of variables that we would like here after our SSH keys to kind of allow us to parameterize the drop a little bit more. The first one we're going to do is region, because I want to be able to set my DigitalOcean region. Right now we're at NYC2. Maybe I don't want to be in NYC2. Maybe I want to be able to decide that whenever it's time for me to run it. Variables do have a little bit more syntax than the typical DO token variable. They have a type, which we're going to do here as a string. So this will tell Terraform, hey, this is the type that you're expecting. And a good thing to have for them if you want your Terraform to be able to execute without any input from the user, you're going to want to set a default value. Now, if you're like, hey, I don't want them to be able to execute this without them, manually setting my region, then you would just leave this default value out. You can still use the type to tell it to expect a string, and I assume that you could probably do that with a variable DO token. It's not that big of a deal. But you want to make sure that people do that, then fine. However, if you want your Terraform to always provide a happy path, a path of sane defaults, then you would do this by setting default values for these. The other variable we're going to make is droplet count. And this one is going to be of type number, and we're going to set the default to 1. That's a good way to not hurt our credit cards. And why is that one not lighting up purple? Does it just hate me, or did I mess up? We're going to hope that it just hates me. And then the last thing we're going to set is the droplet size. If you've never used the DigitalOcean tool doctl, you can use this to figure out all of the available droplet sizes, or there is a really cool tool that one of my coworkers created that's slugs.do-api.dev that I use to figure out what all of these slugs are, because I sure don't know them. So again, to save money and to make our happy path cost as little as possible, we're going to go ahead and set this size to 1 virtual CPU, 1 GB of RAM on the standard droplet size. Okay, so now we've created more variables. Now we actually need to be able to use them. And basically all we do here is we just come and replace them. We can say var dot go away. What did I call this? The name. Oh, I clicked on the wrong thing. We'll do that in a second. Ignore the man behind the curtain. Region. We're going to do var.region. Oh my goodness gracious. I wish this output would stop showing up. Why is it doing that? Size. We're going to do var. Okay, that is getting really old really fast, but I guess we're just going to have to live with it. Go. Wait. Turn auto scrolling off. Okay, that makes sense. Hopefully that works. If it doesn't, I'm going to be upset with VS Code. We're going to do var region, var size.droplet size, and then what other one do we do? Droplet size. Oh, count. Okay. So, quick thing for those that have used Terraform before. As you can see, I'm not doing the old school Terraform syntax anymore. So anybody who's used Terraform before version 0.12 will recognize this syntax, very Ruby-esque to me, of the variable interpolation syntax. In 12, one of the major differences that happened is if you are not interpolating your variable data in any way, so say you just want the data that's passed in, you no longer need any of that interpolation syntax. Necessary, how if you want to actually combine strings with variables and stuff, then you still need the interpolation syntax. Another thing that I think they added in 12 is you can no longer use the word count as a variable name because it's now a reserved word in Terraform 12. What you do now is count is the number of the resources that we want to be able to create. So now we just do a var dot, oh my goodness gracious. Is it because my mouse is there? Let's hope with that. We do a var dot, okay, we're just gonna have to figure out. The language server crashed 5 times in the last 3 minutes. Well, that's great. Var.droplet count. Let me just really quickly. Woo. I was hoping that somebody really quickly posted in the chat how to fix that. But I don't remember, so it's fine. I don't care about the dang language server. Shushity shush. Anyway, nobody got time for that. Okay, so now we have our droplet count. Whenever we pass in variables now, we will see that it is set. So Terraform plan. Ooh, I made a boo-boo. Aha! Okay, I did make that boo-boo, and I made the same boo-boo whenever I was originally... Oh dear, I closed my tab with my code. And I remember how to fix it, but I want to remember my explanation. Okay, so now that we have the ability for multiple droplets to be spun up, we have to change our output. Because this worked when there was one droplet, and we knew there was one droplet. But now there has the potential to be more. So for us to be able to do more, we simply come over here to DigitalOcean_droplet.asterisk.ipv4 address. Essentially what this does is that the count will create indexes of this. So like if I say 3, there will be droplet 0, 1, and 2. And then this star will be the one that gets replaced with that droplet during the execution, and we'll print them all out, all of the IP addresses out in a list form. All of this happens under the hood. You really don't ever see this. So what we can do now is we can do a Terraform plan. Apparently, I'm really bad at things. Because DigitalOcean Web has count set, its attribute must be, did I not save? Ah, ha, ha, ha. I'm silly. And as you can see, it still works. It works the exact same way that we expected it to work from the last time, because we have sane defaults. But now say I want to actually stand up 3 of these. How much time do I have? Ooh. Okay, so say I want to stand up 3 of these. I can do -var and then, how do I do the -var? Is it, you know what? I don't remember off the top of my head. Var foo equals var. Okay, so Terraform plan -var, and we'll say droplet count equals 3. And now you can see here in the plan that we actually have 3 to add. The thing is that I don't typically use the command line arguments. Usually, the thing that I personally do is I create nyc3.tfvars, and we're going to also create one that's called sfo2.tfvars. What I do here is I usually create all of my variables inside of a Terraform vars file, and then I pass this entire variable thing in. I don't want to do -var, -var, -var for all of them, because even though right now it seems like it's not a lot, it is actually, they can get relatively large. So for NYC, we're just going to do the region of NYC3 and the droplet count of 3. And then what we're going to do for SFO2, though, is we're actually also going to change the droplet size. We're going to pretend that maybe our cluster in San Francisco is getting hit more. There's more traffic that's being routed to it. So we actually need slightly beefier machines to process the request. So we're going to do a little bit different with that. What we do now is we do a Terraform plan it's var file -var -file equals, and we're going to say sfo2.tfvars. And we're going to hope that I can remember that right off the top of my head. And yes, I did. Ha ha ha. And it works. As you can see, this will create 10 droplets for us. They are in the SFO2 region, and they are of the larger size that we want. So now, if I do that and I say nyc3.tfvars, we will see, something similar. So let's go ahead and apply this real quick. I have to pick it up a little bit. I'm running out of time. I think I can finish what I want to do in the next 10 minutes. So we're going to go ahead and apply this. And we got to wait. If only I could whistle today. We are waiting for the 3 droplets to be spun up. Don't need that anymore. That's gone. Oh, great. Error, waiting for droplet to become ready. I do not know what happened with that. So let's see if we can actually run a Terraform destroy. Sometimes Terraform gets in weird states. If we can actually run a Terraform destroy, there's nothing to change. So unfortunately, Terraform got into a weird state with that. And we will go ahead and just destroy these really quickly. I probably messed this up somehow, somewhere. But that's fine. We will, while we're doing that, because I don't want to waste a little bit more time waiting on that, we are going to talk about some string interpolation on the name, because I do want to change the name real quick. I don't think this was the problem, but you never know. So what we're going to do now is, as you saw, they did come up properly, but however, unfortunately, something happened with Terraform and it dropped. But they all had the same name. They were all called Web 1. That's moderately irritating. So what we can do now is do some really clever string interpolation to make it where all of our names are unique. So, no, stop. What we're going to do with that is we're going to do web-var.region, and then we're going to do another dash count.index plus 1. The var.region will pull the NYC3 in, and that will allow us to, it'll be called web-nyc3, and then dash, and then count.index is a variable inside of this resource, and each one of them are going to have an index, either 0, 1, or 2, because we're creating 3, and I do the plus 1 because I like it to be 1, 2, 3 inside of my terminal. So we're going to try to plan this again. Okay, we have 3 to plan, and if this doesn't work, then we're just going to move on to something else. Okay, so the droplets are being created. They're still coming up as web 1. Did I do this and not save the dang file? Oh, I'm such a silly. I didn't save the file. Ay vey. I don't know why I'm getting really bad at that. I'm moving over. And it worked this time, though, so it's fine. So they're all named Web 1. The dang name interpolation didn't work, but hey, mistakes happen. So yes, as you can see, now we have the server IPs of our address, of our droplets. And the interesting thing that we do here is if we do a Terraform plan and we do the -var file again, but we do SFO2, it's going to do the plan again, but look at this. 3 to destroy. This is not good. This is actually really not good for us. This is going to tear down our NYC cluster and stand up the SFO2 cluster. What we have to use for this now is a tool called Workspaces. So what we do is we create a Terraform workspace, and then we say new, and we're going to call it SFO2. The way that Terraform works is that it stores the state files, the default state file in the directory, but when you create a workspace, it creates this Terraform state.tfstate.d directory. What that will do is that will store the individual states, and then you don't have to worry about conflicts. There can only be one state at a time inside inside of your default directory. So now if I do a Terraform workspace list, I can see SFO2 and default, and now I'm in that. And now if I do a Terraform plan on SFO2, I have 10 to add, 0 to change, and 0 to destroy, which is awesome. We're not going to really lose our stuff, and now we can just switch back into the default one. Actually, personally, what I would do is I would switch back into the default one, delete it, and then I would probably restand up NYC3 in another workspace to keep the workspace segregation working. I think it's really good to keep them separated so that way, and not really use the default workspace unless you absolutely have to. Okay, and then the one other thing that I am going to show you before I move on to the next section, and then I'm going to have to unfortunately speed through this because this took a little bit longer than normal or than I expected. We're going to change our life cycles. So what this means is that currently, if I were to, let's go back to the default workspace. Terraform workspace, select default. If I were to change something in here, maybe I change the count, or let's change this image Ubuntu 1804 to 1604. If I were to change this, what it's going to do is it's going to actually tear down my old resources and spin up 3 new ones, because there's no happy path for Terraform, for Terraform and DigitalOcean to be able to convert your operating system on the fly, downgrade it to an older LTS. So what it will do is it would destroy the old infrastructure and then stand up the new infrastructure. This can lead to outages because you are potentially deleting a production cluster without before the new stuff comes up. By adding this create before destroy, it will actually bring up we're going to do NYC. It will bring up the cluster before, and then it will destroy the old one. So as you can see, there's 3 to add, 3 to destroy. What we're going to do now is we're going to apply this. And we hit yes. And if we go over to the DigitalOcean thing, we can see now that our web is being updated. We are getting the new ones, and the proper name is there. So it is creating the new ones, and when it is done creating our new droplets, it will destroy the old ones from underneath us. Now, while this is a cool feature, and I would say that it is pretty, it's pretty awesome that this is in there, the likelihood, especially if you're running like, say, a large cluster of like maybe Kubernetes nodes or of Nomad or Mesos Marathon nodes, is that just because these became healthy, if you are connecting to a configuration management tool on the back end that's going to, say, like provision these, is that will probably still be going before you tear down your clusters. So you always want this in here in case for some reason it fails, and like if something were to fail in the creation, it would have failed creating the droplets, but it wouldn't have deleted your old cluster beforehand. Whereas had you done it the other way, it would have deleted your old cluster, stood up a new cluster, and then failed, and now you have no cluster, and you have no production, and the people are losing money and very upset with you. So it's always a good thing to do a create before destroy if the environment means a lot to you. But just because DigitalOcean says your node is healthy and ready and starts the destroy on the Terraform side does not mean your configuration management tool has finished provisioning a cluster. And if you were doing this on like, say, 2 we'll say, Mesos Marathon clusters or something where you're running Docker containers or Kubernetes clusters or something, it's unlikely that all of those droplets have been migrated over first yet. You're probably going to need to do some sort of drain on your nodes to drain over into them. So it's a good feature, but I would not use it. Use it, carefully. You have to think about that. So now we go over, and that is essentially Workspaces. I'm going to try to really quickly get through part 4. If you have to drop off, thank you very much for attending. I'm going to keep going until the people that run the webinar tell me that I have to go away. So this went a little bit longer than I was anticipating, but hey, I'm having fun. I hope you're having fun. So here we go. The next part, for part 4, we are going to finish everything up. We're going to talk about resource dependencies, which are basically resources that need attributes from other resources before they can be built. We're going to talk a little bit about Cloud Init, which is a provisioning tool for cloud-based virtual private servers. And our complete infrastructure is going to look something similar to this. We're going to have a load balancer with a DNS record in front of it, and then we're going to move, which is going to point to a backend cluster. And we're going to go back to VS Code. What I am going to do real quick, though, is I am going to go ahead and just set up a background destroy to get rid of all of these because I do not want them. And while I'm doing that, we're going to go ahead and move on to part 4. So what do I need to add for part 4? We need one more data provider in here to get our DNS records. So if we go over to here and we go back to, I don't need that download page anymore. We go over here, we need DNS records. So it's called record, DigitalOcean record. And this is how we are able to check and see if we have access to a zone and like TTLs on records and stuff. So, and this is also a great place for us to put our domain name and be able to access it programmatically from within inside of our resources. So we're going to go ahead and do another data source, data DigitalOcean _ domain. And then we're going to just call it web. And I'm going to use a domain that I do have registered to myself, and I also have it configured inside of DigitalOcean so that DO's name servers are the authoritative name servers, and that DigitalOcean can create records on my behalf. You do have to have all of that set up before you can do that. If you look in the README for this section, there's links to how to do it in the README. I think I wrote some pretty cool readmes. Not gonna brag, gonna brag a little bit. Okay, now all we're gonna do is we're gonna come down here and we're gonna add user data finally to our droplets. So what this does is the user data uses a here doc to basically write a YAML file that we can use. And let me close this so you can see it a little bit better. So what it says is packages is one of the defined cloud init things that allows me to create an engine, allows me to install Nginx. Then basically what I'm going to do is I'm going to do a run command when just execute a shell script that's going to echo. It's basically going to append the host name to the Nginx Debian HTML file. Whenever I was doing this, I for some reason couldn't get the host name to work in this syntax, so I'm actually interpolating the data. It will be the same since it's the same resource, so it's kind of like doing the host name, but kind of a cheat. In reality, the whole point of this is I want to be able to show you when we're going through the load balancer that we are round-robining through our droplets as we're serving the resources. The next thing that we need to add is we need to actually add a load balancer. So we're going to add a DigitalOcean load balancer, and I'm really boring. We're just going to call it web. We're going to copy and paste from my GitHub files because I'm lazy, and then I will just explain it. Name, we have to have a name for it. We're going to call it web dash and then the var.region. So basically this will be web dash NYC3, web dash SFO2, whatever. We have to create we have to have the region set, and the region has to be, I believe the load balancers have to be in the same region as the droplets. So that's how it's going to work. And this is where this section right here is where the dependent resources come in. So we have to get the droplet IDs that we created to tell the load balancer where to put them. The only way we can get that is if we pull we create this resource and then we access the attributes from that resource inside of another resource to create it. And these have to be sequential. I'm like 95% sure. I think they have to be sequential in the file, but maybe Terraform's smart enough to do the dependency graph. Actually, now that I'm thinking about it, I'm pretty sure it is. But who knows? It's been a long time since I think I remember that biting me in the butt like in 2016, but who knows? So anyway, for best sake, make it a nice flow. So you set your DigitalOcean droplet web IDs here, and this will pull the IDs of the droplets and then set the load balancer behind it. And then you set up your load balancer forwarding rules. I don't have time to go over those today, but again, in the README, there is a link to how to write DigitalOcean forwarding rules. So basically what we're doing is we're going to say on the load balancer, take any HTTP traffic on port 80 and forward it as HTTP traffic to port 80 on the droplets. So it's going to pass our HTTP traffic through. Again, lifecycle create before destroy, great thing to do. The last thing we're going to do is add a DigitalOcean record for adding a DNS record. So it's another resource that we have. Again, boring, call it web. Domain data.digitalocean_domain.web.name. We could have just hard coded our domain instead of just using it the way we did with our data resource up here. But hey, this is programmatic and looks nice. We're going to create an A record, and we're going to make sure that it's in the same region, and we're going to set the value of the DNS record to the load balancer web IP, and we're going to set our time to live to 30 seconds because we iterate over this relatively quickly. Once you have that, like once you have it and it's more established, you don't really need to worry about, you can set the TTL a little bit longer so you don't have to worry about invalidating DNS cache so often. And then we're going to create one more output for servers, and we're going to, that's not the right thing. I copy pasted the wrong part. We're going to create one more output, and we're going to call it load balancers. And we're basically going to get the IP address of our load balancer whenever we do it. So all in all, what we've added is we've added a little bit of user data. We've created a load balancer in front of our droplets, and we've given that load balancer a name. So what I'm going to do is I'm going to Terraform. First, I'm going to clear so we can start at the top. Terraform workspace. Sorry, had a brain fart. Workspace new NYC3. Okay, now we are in NYC3. So now I'm going to do a Terraform plan. var file is equal to the nyc3.tf vars. We're going to go ahead and plan that. It looks okay. I know you can say, hey, I can always just look at the plan during the apply. The answer is yes, but this makes me feel safe, so I do it this way. It only takes one bad Terraform push taking out of production and causing an outage that you start being a lot more careful. I had one of my architects at my last job said there are old sysadmins and there are bold sysadmins, but there are no old bold sysadmins. So it's pretty interesting concept. I agree with that a little bit more and more each day. So what we're doing now is we're actually going to create this load balanced with all of these resources inside of DigitalOcean, inside of NYC3. And while we wait on the Terraform to create the droplets, we have to rechef. There they go. Okay. Did I forget to save again? Oh my goodness gracious. This has got to be insanely entertaining for everybody who's watching this, because like I've never had this kind of problem with saves before. I always remember to save when I'm doing it for myself, but live coding it, it makes you make weird mistakes. Hey, at least I'm forgetting to save and accidentally spinning up a couple of resources instead of like stuck on like, I'm missing a semicolon and everybody in the chat is screaming at me. Let's see if everybody's laughing at me in the chat while we wait on this to destroy. Forgot to save. Ha, thanks guys, love it. Okay, let's try this again. We're just going to apply it this time, living on the edge. So yes, the demo gods always strike. They get you every time. While we're waiting on the resources, the first time I ever gave a talk at a conference, I was doing a talk on pfSense, which is a FreeBSD-based firewall. And in the middle of my demo, the internet went out. And I'm like, well, it's really fun to demonstrate, firewall and IP rules whenever I have no way of accessing my resources that are in the cloud. So I normally record my demos beforehand, but I decided, hey, let's try the live coding. And I feel like the live coding, we're getting some laughs and giggles out of it. So it's worth it. We are waiting on us to create the resources. Now, this is one thing that you will see when you are writing Terraform is as your Terraform gets more and more complex, the amount of time it takes for Terraform to complete its tasks does become longer. I have seen Terraform states that are so complex that they take 10, 15 minutes to completely do. So hopefully we are doing okay over here as we're waiting on the load balancer to come up. It looks like maybe one of my droplets is being a turd. Let's refresh the page. No, it was coming up. So while we wait on the load balancer, oh, file.autosave. I'm gonna have to look at that, Rolando. That sounds really nice. We just sit here and wait while we wait for our stuff. Okay, it got an IP. There we go. Good. See, it just takes a little bit. Sometimes the load balancers go quickly. Sometimes it just depends on the underlying infrastructure that's provisioning them. I think this is called nyc.egger.codes. And ta-da, we now have a load balance, as you can see, as it round robins through my my infrastructure. So I'll do it real quick just for fun and giggles. Terraform workspace select SFO2. And then what we're going to do is we're going to apply again, but we're going to do the SFO2.tfvars. And now we're going to spin up 10 droplets, which might take a little bit longer. And now I will have both of my resources waiting once this is done. So then I will have a small cluster on the East Coast that is taking traffic through a load balancer. Then I'll have a slightly larger cluster on the West Coast that is taking traffic through its load balancer. And this is, kind of one of the ways that you can easily create, small load balance clusters and stuff. I am just going to go ahead and we're going to refresh this. Is it showing up? There's everybody. They're all coming alive. As all of my things come up. I guess a couple of random tidbits about Terraform that I can think of while we're waiting on this. So one of the things that I did not go over the entire time that I realized that I forgot is I never showed you how I'm getting my DigitalOcean token. You're not seeing me put it in the TF-vars file. It's not in a variable, but yet it's all magically working. Terraform has one other way of accepting inputs, and that comes in the form of environment variables. If you have a environment variable that is TF all caps underscore var all caps underscore, and then the name of the variable that it's defined within Terraform, you can access your variables from there. That's what I would recommend doing for your sensitive information, API tokens, passwords, things of that nature. One, because if you're in a CI/CD system, you can manage them in a secrets manager and then pass them in as environment variables during execution, which is really good. You can easily do that in Jenkins. And it keeps it hopefully out of like sensitive eyes. Like you don't want to be because your TF-vars file, you could commit. As you can see over here, like our TF-vars file, there's nothing super sensitive in here. So we could commit these, and that way I have a complete visible view of how my poop. I can't think of how my infrastructure looks. Sorry, I had a brain fart. One of the other ways that we did it at my last job that I wasn't quite sure if I liked, but it worked, was we actually had every environment in a different Git branch. So that was really cool. We did that, and it was all good. Hopefully my resources are coming. Okay, those are still going up. I will check those at the very end of the presentation, but let's just go ahead and get back to the presentation so we can go ahead and wrap up. So that, as you can see, that was the complete infrastructure. SFO2, as I said, as your infrastructure gets larger, Terraform can take longer to spin up. That's all I have for this time. Thanks very much for attending. Be sure to be on the lookout for more DigitalOcean workshops and webinars like this, either from me or other developer advocates like my buddy Fred, who did one recently on Kubernetes. It's great. If you haven't seen it, go check it out on YouTube. If you have any ideas for things you would like to see in future webinars or workshops, leave them in the comments in the chat. We're going to go back over those and look at that. And we would love to get your input on like the things that you, the community, want to see us do educational resources on, and try to take your feedback in that. And thank everyone. I want to thank everyone for attending. I know some of y'all are, in time zones where it's really, really late. It's 1:12 p.m. or 1300 hours here in Austin, Texas, which is where I'm based. So I'm actually about to go get lunch after this. We're going to check my resources a little bit more. Come on, buddy. They're still going. So we're just going to pretend that worked. It would have worked the exact same way. You just have to imagine bigger infrastructure. Thank everyone. I want to thank everyone again for showing up. And it was